In this video, I will explain how to solve rational inequalities. So let's work through a couple examples. Let's say we have x plus 5 over x minus 8 is less than or equal to 0. So we want to figure out for what values of x make this left-hand side less than or equal to 0. So the way that we do that is we first set the numerator equal to 0 and solve for x, and then set the denominator equal to 0 and solve for x. So let's do that. Let's say we have x plus 5 equals 0 and x minus 8 equals 0. Okay, on this side, to solve for x, we can subtract a 5 from each side. That leaves us with x is equal to negative 5. And over here we have x minus 8 is equal to 0. So we can add 8 to each side. These 8's cancel out, and we're left with x is equal to positive 8. So now what we can do is we can draw a number line. And let's say this side is extending towards positive infinity. This side is extending towards negative infinity. And we can write negative 5. And our other point of interest is x is equal to 8, so 8. So for this negative 5, if we plugged in a negative 5 for this equation, we would get negative 5 plus 5, that's 0 over something. But 0 over anything is 0, so it would be equal to 0. So since we have since negative 5 is a valid value, we're going to go ahead and draw a closed-in circle at this point, since negative 5 is a valid number that we can plug in for x to make this expression true. But over here for the 8, we're going to draw an open circle. Because if we were to plug in an 8 for x, we would get 8 minus 8 in the denominator, which is 0, which would make this whole left-hand side undefined. So 8 is not a valid answer. So we're going to draw an open circle to indicate that 8 is not allowed. Now what we need to do is we need to see the 3 regions on this number line. We need to pick a number from each region and plug it in for x to see if this original expression is true. So let's check out this first region. We have negative infinity to negative 5. Let's pick a number in here and plug it in to this expression. So let's say negative 6. So let's plug in a negative 6 for x. Negative 6 plus 5 over negative 6 minus 8 is less than or equal to 0. So a negative 6 plus 5, that's negative 1. Negative 6 minus 8, that's negative 14. It's less than or equal to 0. So a negative divided by a negative, that's going to produce a positive number. So is a positive number less than or equal to 0? No, that's not. So that's not true. So we're going to write a no right here for this region. So these values for x are not valid. They do not produce an answer that's less than or equal to 0. All right, let's check out this next region from negative 5 to positive 8. Let's pick a number in here and plug it in for x. So 0 would be an easy number to plug in, so let's do that. 0 plus 5, 0 minus 8 is less than or equal to 0. So we get 5 over 0 minus negative 8, that's negative 8. It's less than or equal to 0. So is negative 5/8 less than or equal to 0? Yes, it is. So that produces a yes in this region. So any value between negative 5 and 8 produces a value less than or equal to 0 in this original expression. Now let's check out our last region from 8 to positive infinity. Let's pick a number in this region and plug it in for x. So let's just say 9. So 9 plus 5 over 9 minus 8 is less than or equal to 0. So 9 plus 5, that's 14. 9 minus 8, that is 1. So 14 divided by 1 is just 14. So is 14 less than or equal to 0? No, it's not. So we'll write a no for this region. So we can see that the only valid values for x that we can plug into this original equation and make it true are between negative 5 and 8. So if we want to do that in interval notation, we can write it like this. Negative 5 with a bracket, because negative 5 is part of the solutions. It's part of the values that you're allowed to plug in for x, up to positive 8. And we'll write a parentheses around this positive 8 to indicate that 8 is not a valid value that you can plug into x. So any values between negative 5 up to 8, but not including 8. Those are the valid values for x that you can plug into this expression and make it true. All right, let's check out another example. Let's say we have x minus 4 over x plus 6 is greater than 0. So again, we need to figure out what values of x can we plug into this left-hand side to make this expression true, to make this left-hand side greater than 0. So again, we're going to set the numerator equal to 0 and solve for x, and we'll set the denominator equal to 0 and solve for x. So let's do that. X minus 4, set it equal to 0, and the denominator x plus 6, set that equal to 0. So let's solve for x. So here we can see we need to add a 4 to each side, plus 4. So x would be equal to 4. And here to get x by itself, we need to subtract 6 from each side. So we get x is equal to 0 minus 6, negative 6. So these are our 2 points of interest. So let's go ahead and draw those on the number line again. So we've got this number line. Let's say it extends to positive infinity over here. And over here on this left side, it's extending towards negative infinity. And we'll mark our 2 points of interest, so negative 6 and positive 4. Now, recall, if we plug in a negative 6 into this original expression, negative 6 plus 6 in the denominator, that's equal to 0, that would produce an undefined. So we're going to draw an open circle at negative 6 to indicate that negative 6 is not a valid value that we're allowed to plug in to make this expression true. And then over here we've got a 4, but if we plug in a 4 in the numerator, we get 4 minus 4 is 0. So 0 over anything will be 0. So that's not greater than 0. It would be equal to 0. So 4 is also not a valid solution. So we're also going to draw an open circle at 4 to indicate that 4 is not a valid solution. So once again, we've got these 3 regions. We have one that ranges from negative infinity to negative 6. This region ranges from negative 6 to positive 4. And this region ranges from 4 to positive infinity. So we want to pick a number in each region and plug it into the original expression and see if it's true. So for this one, let's pick a negative 7. So let's say negative 7 minus 4 over negative 7 plus 6 is greater than 0. So negative 7 minus 4, that's negative 11. Negative 7 plus 6 is negative 1. It's greater than 0. So a negative divided by a negative, that produces a positive number. So that's just 11. It's greater than 0. So is this true? Is 11 greater than 0? Yes, it is. So we'll write yes for this region. And this indicates that any x values between negative infinity and negative 6 do indeed produce a value greater than 0 in this original expression. All right, let's check out this next region. We have negative 6 to 4. Let's pick a number in this region and plug it in for x and see if this expression is true. So let's pick 0 just to make things easy. So let's say 0 minus 4 over 0 plus 6 is greater than 0. So 0 minus 4, that's negative 4. 0 plus 6 is a positive 6. It's greater than 0. So is negative 4/6 greater than 0? No, it's not. So we're going to write a no for this region right here. So values in between negative 6 and 4 do not produce a number greater than 0. All right, let's check out our last region from 4 to positive infinity. Let's pick a number in this region and plug it in for x and see if it produces a value greater than 0. So let's pick 5. Let's say 5 minus 4 over 5 plus 6 is greater than 0. So 5 minus 4, that's 1. 5 plus 6 is 11. Is 1/11 greater than 0? Yes, it is. So we'll say yes for this region. So values between 4 and positive infinity do indeed produce a number greater than 0 in this original expression. So if we wanted to write our answer in interval notation, we could write negative 8 or negative infinity up to negative 6, and we'll write a parentheses to indicate that negative 6 is not part of the valid solutions, union with 4. Remember, we use a parentheses again to indicate that 4 is not part of the valid solutions, up to positive infinity. So these are the values for x that we're allowed to plug in here to make this expression true. Thanks for watching.